The programming language C is a foundation for most computer programmers since its introduction almost 50 years ago. Despite its popularity and relative ease of use for software engineers, modern developments and requirements for safety and cybersecurity have challenged the confidence and reliability of critical control systems built on this language. To overcome some of these challenges, researchers are constantly developing new applications and platforms to provide secure and reliable methods in using C. The recent introduction of Frama-C software analysis platform, developed by a team of researchers in France, is one such example. Join us as we meet Nikolai Kosmatov from the CER list, the Software Safety and Security Lab in Palaiseau, France, as he discusses the dogged pursuit of bug-free C programs, the Frama-C software analysis program.
Frama-C was created in 2008. The first release was in 2008, and it was a joint project between CA List and INRIA. The need for software verification is motivated, first of all, by the critical level of software today, which is present almost everywhere. Software providers must ensure that the software they provide respects necessary safety and security constraints.
Frama-C has been successfully used by several industrial partners in demanding and critical applications. These include EDF, the main French electricity provider, who demonstrated the absence of runtime errors in nuclear power shutdown software. NASA used Frama-C applications in the use of air traffic management systems, and Airbus applied Frama-C for use with critical onboard aircraft software.
The core plugins presented in the paper, EVA, Pathcrawler, WP, and eAxle, implement the most basic techniques which were proposed for some of them 50 years ago, but they become efficient much more recently, only in the recent 10-15 years, and they are also the basis for many other analyzers, for many other techniques which are used in combination with those techniques and which provide some new solutions.
Each of the plugins offer different functions. EVA detects potential runtime errors at compile time. WP provides functional properties. eAxle checks program properties at runtime, and Pathcrawler generates unit tests.
I show how to use value analysis plugin EVA to show the absence of runtime errors in C code. This is a real-life code AES for the ES encryption algorithm from the Contiki operating system. So here we can see that in one of the files, the value analysis plugin detects a problem. There is an assertion which was generated which shows that this property is not satisfied. EVA detects an access issue because the array key cannot be accessed at index 15, because if we look into the values of the index, we will see that the values can vary between 0 and 15. And indeed, it cannot show that this index is valid for this array, because in reality, in this example, I introduced a small mistake in the function where this array is too short. It contains only 15 elements, so it cannot be accessed at index 15. Value analysis plugin detects this access issue. If I run the same tool on the same code after correcting the issue, we will see that now there is no problem, there is no issue detected by EVA because there is no potential errors. The code is correct. So one of the goals of Frama-C is to reduce the cost of the verification activity. That is why new techniques are aimed at increasing the level of automation of the verification so that industrial users can verify their software more easily.
Find out more in the contributed article, The Dogged Pursuit of Bug-Free C Programs, the Frama-C software analysis platform, in the August 2021 communications of the ACM.